Hello, ladies and gentlemen. This is Mr. Paul Lee with AP Physics 2, a lesson on density. What you see right there on your screen is a density tube, and that is one of the things that we'll be able to do in the classroom. Without further ado, bring out your pens and pencils and pieces of paper, and let's get cracking. All right, so density. What is it? It's about how many molecules an object has per limited amount of space. So if you look at this diagram below, if it has a lot of things jam-packed, that is something what we call a solid, or it's highly dense. And then you can go down to the lower spectrum where there's not very much there. And then that's what we get with lower density objects. That's what we call gases. And anything in between is what we can safely assume is going to be liquids. Some liquids are more dense, some liquids are less dense. So density is, in its most simplest definition, is the mass per unit volume. And of course, from there we can come up with an equation. And that equation looks a little bit like this. Density is the mass per unit volume. That fancy P right there is a Greek letter rho, and how you write that is you give a P a kind of like a J tail, okay? And of course mass with the variable M and volume with the variable V. So if you were to write it out, it kind of looks like this. Or actually, it does look like that. Okay, very important to know, the density of water is 1,000 kilograms per meter cubed. Now notice how we are using SI units. The SI unit for mass is kilogram, and the SI unit for volume is meters cubed. An easy way to remember this is think about, like, if you ever had your heart broken because your crush like dumped you, and oh God, it hurts. Oh, I don't want to go to school today. Why? They broke up with me, right? And so if you think of it that way, like, your heart feels very dense because your heart is broken. How dare they? Alright, so let's do a practice problem. So what I want you to do right now is to pause and copy this problem while we solve it together.
Alright, ladies and gentlemen, I hope you wrote down the problems because we are about to solve it together. So we have a block of wood with a mass of 27 grams with a volume of a block with 3 centimeters each. Now, what I'm going to do to start us off is I want to convert the 27 grams from grams to kilograms. And so if we have grams in the top, or the numerator, we want to get rid of it, so we're going to put grams in the bottom, and we're going to put the conversion unit at top. For every 1 kilogram, we have 1,000 grams, and that gives us 0.0, let's see, 27 kilograms. All right, now our volume here, we have a 3 centimeter block by 3 centimeter block by 3 centimeter block, and so we can write out that equation of 0.03 centimeters cubed. Now, if you do the work, what we get is 0.123 427 meters cubed. All right, now that we have all of the values for the variables that we need for the equation, I'm going to put it into my equation. Rho is equal to mass times volume. And if you plug that in, we get mass for 0.027 and volume, this ginormous mass. And what we get is a density of 1,000 kilograms per meter cubed.
All right, now that we solved that problem, let's do a little game called Does It Float? Now, all of these values are found on the engineering toolbox, and is a public tool that you can use as well. So we have a apple seed with a density of 513 kilograms per meter cubed. Does it float? Yes. Yes, it does float. Remember, if it's less than 1,000 kilograms per meter cubed, it will float on water. Now, how about paraffin wax? Now, that's just a fancy way of saying, like, candle wax. Does it float? Yes. Yes, it does float. How about crushed ice? Have you seen crushed ice float?
Yes.
Yes. Yes, it does float. Remember, if it's less than 1,000, it floats. How about tar? The things they put on the side of the road or in the road to fix the road, or trap dinosaurs so that after millions of years you can go to the tar pits and still find their remains. Does it float?
No.
No, it does not float, because tar is more dense than water. It is above 1,000 kilograms meters cubed. Now, on to specific gravity. Specific gravity is the ratio of a density of a substance to the density of water. Okay, so the equation, specific gravity, we'll just write it as Sg, is the density of liquid. Remember, rho, it's divided by the density of water. Okay, so let's think about this. If specific gravity is less than 1, or less than 1,000 over 1,000, which is 1, will it float? Yes, it will float. For example, the density of ice is about like 800 and something, and ice floats. Okay, so you have to think about it. What about the density of tar? It was above 1,000. So will it float?
No.
No, it'll sink.
Yay!
All right, now here's an example that I think is important for us to know. Okay, the density of ethanol, which is a alcohol, is 789 kilograms per meter cubed. What is the specific gravity? All right, now bring up those equations and try solving yourselves. In the meantime, I'll solve it with you. Specific gravity, the equation is the density of the liquid divided by density of water. So I'm just going to rearrange the subscripts a little bit to get the density of ethanol divided by the density of water. Plug in my numbers, we get 789 kilograms per meter cubed divided by 1,000 kilograms per meter cubed. Now notice what happens with the units. When you have the same units in the numerator and the denominator, they should cancel out. So we get specific gravity of ethanol to be 0.789. Will it float? Yes, it will. Very good, because it is less than 1. Now, SGOP, or SGLFP, or the specific gravity of your P, or the gravity of the situation of your urine. Now, when you go to the doctors or when you get your urine analyzed, they look for very specific things. The specific gravity of urine is slightly above water. Okay, it ranges from 1.001 to about 1.035. Now, I'm about to get into gross territory. Sometimes when people don't flush after they peed, you can actually see the pee sink to the bottom.
Yeah.
Has that ever happened to you when you're using the school bathroom? Someone forgot to flush and they left that mess. Nasty. So what does this mean to us in the medical field? Some of you might want to be doctors, and so pay attention. If the specific gravity is slightly off or off, you could have a condition where you just drank a lot of water. It's a compulsive consumption of water called primary dipsia. Or also a very important test to get tested in. You might have your kidneys might have the inability to concentrate urine, and that's what we call the diabetes insipidus. Now, if you are caught with the next one, intentional dilution of urine with water, you could say that you're in trouble, because usually when somebody has this as a test result, that means they're trying to pass the urine test after they took illicit drugs by just drinking a lot of water to try to dilute it out. And if you do that, you're in trouble.
Wait, no, stop.
Anyways, thanks for joining me with AP Physics 2 Density.